So, hello friends, good evening. My name is Anirudh Kumar Singh, and we are continuing our chapter trigonometrical ratios after a long time. And we are on the exercise number 17, and we have this question which states that in the figure 1 given below, triangle ABC is isosceles triangle. AB is equals to 5 centimeter, AC and B. AC will also be equal to 5 centimeter because it is given to our question that AB is equals to AC. So AC is equals to 5 centimeter, AB is equals to 5 centimeter, and BC is equals to 6 centimeter. And we have to find sin C, tan B, and tan C minus cot B. And this is our figure. So first we will find all the sides. As we have given all the sides, but in order to find the trigonometrical ratios, first we have to find a 90-degree angle. So we will make another triangle and we will drop a perpendicular to this, or we can write here only. After giving our question, we will drop a perpendicular to this triangle, and it will create 290 degrees, and both will be same as both the centimeters are same, because first of all there is a rule that in isosceles triangle, if a perpendicular is dropped, if a perpendicular is made in an isosceles triangle, so it means that this line is a midpoint. The line where it is touching is the midpoint of the slanting line which is drawn here. So we can say that here this point is D. We will consider as D. So we can say that in an isosceles triangle, if a perpendicular is dropped, it means that this point is the midpoint of BC. So if it is a midpoint of BC, then it will divide BC into half. So now, as it divides BC into half, so BD will be equal to BC, which will be 6 divided by 2, it will become 3. So BD will become 3 and DC will become 3, as both are equal to each other because of the midpoint. So now we will find the solution. First we will, by Pythagoras theorem, we will find the line AD. So we will, the hypotenuse of this triangle is 5. So hypotenuse is 5, and height of this triangle we will consider as h, and base of this triangle is b, which is 3. 3 is given to us. This is the base. We will take one triangle only which has a right angle. So both the triangles have right angles, and both the triangles are same to each other. Both the triangles are congruent to each other. So we can say that both the triangles are equal to each other or congruent. So we can take any of the triangle. It doesn't matter. Now, by Pythagoras theorem states that hypotenuse square is equal to height square plus base square. Now hypotenuse is 5, which will be squared, which will be equal to height square plus base is 3, which will be squared. Now 5 square is 25, 3 square, which is 9, will be transferred this side for further calculation, and h square will become, after the subtraction, h square will become 16. Now this value will be rooted and it will become 4, and this will also, the square will also be removed from h. Now we have found the value of h, which is 4. Now we can find sin C, tan B, tan C minus cot B. So this was the procedure for finding the line AD. Now we will find our values. Our first value states that sin C. So first we will write here sin C. Now as there is C written here, so first we will find that where is the angle C. So if there is the angle C, then this triangle will be considered, which is triangle ADC. So sin C we have to find in triangle ADC. Sin C's value will be taken from triangle ADC. So sin has the formula of height divided by hypotenuse. So height is AD, which is 4, and hypotenuse is AC, which is 5. So now we have found the value of sin C, which is 4 divided by 5. Now we will find tan B. So as B is written here and B is this angle, so we will consider this triangle. Although it doesn't matter because the triangles have same sides, as AB is equals to 5, AC is equals to 5, and BD is equals to 3, and DC is equals to 3. So all triangles, both the triangles have same sides. It doesn't matter what triangle we take. but we have to take in case of trigonometrical ratios. So now we will take triangle ADB. In triangle ADB, tan has the formula of height divided by base. So height of our triangle is AD and base of our triangle is BD. So height is 4 and base is 3. Now we have found the value of tan B also. Now we will find the value of tan C minus cot B. So our third, which is tan C. In order to find this value, first we have to find tan C and cot B. So tan C, this triangle will be considered triangle ADC. Tan has the value of height divided by hypotenuse. So height is AD and hypotenuse is AC, which will become 4 divided. Tan has the value of height divided by base. So base of a triangle is DC. So 4 divided by 3. Now cot B. Cot B is just reciprocal of tan, that is base divided by height. So this triangle will be considered triangle ABD. So base is 3, which is BD. BD divided by AD, which is the height. Now BD divided by AD, BD has the value of 3 and AD has the value of 4. Now we have find the values of tan C and cot B. Now we will find tan C minus cot B. So tan C is 4 divided by 3 and cot B is 3 divided by 4, which is in minus. Now both the terms will be multiplied as in LCM subtraction. 4 3 will become 12, 4 into 3. Now 3 will be multiplied here, which will become 9 of minus, and 4 will be multiplied here, which will become 16. Now our value will become 7 divided by 12. So we have found the value of sin C, tan B and tan C minus cot B of this question. Now we are moving to our question 2. So this is our next question, which states that in the figure 2 given below, triangle ABC, this is triangle ABC, it is right angle triangle. Angle ACB is equal to theta, is ACB is equal to theta. Theta is written here. AB is 2 units, AB is 2 units and BC is 1 unit. So we have to find sin squared theta plus tan squared theta. Solution. So first we will find this side, which is hypotenuse. So by Pythagoras theorem, we will find which will be AC square is equals to AB square plus BC square. So now the value of AB is 2, which will be squared, plus BC is 1, which will be squared. Now AC square is equals to 2 square is 4, 1 square will remain 1. Now AC square will become 5. Now AC will be rooted and 5 will also be rooted. As 5 does not have a fixed value in this, so we can say that AC is equals to root 5. Now we will find the value of sin squared theta plus tan squared theta. So first we have to find sin theta, which is equals to height divided by hypotenuse. So height is AB and hypotenuse is AC, which is height is 2 and hypotenuse is root 5. And tan theta, so now tan theta has the value of height divided by base. So height of our triangle is 2 and this is 1, so it will remain 2. Now these both will be squared. Sin squared theta plus tan squared theta, which means this 2 divided by root 5 will be squared, whole squared plus 2 will be squared. Now 2 square will become 4, root 5 square, root will be cancelled by this 2, so it will become 5 plus 2 square will be 4. Now for the LCM addition, we will multiply this directly by 5. So 4 into 4 plus. This 5 will be directly multiplied by 4 in order to find the value. Now it will become 24 by 4, which if we convert into a mixed fraction, it will become 4 whole 4 by 5. So we have found the value of our question number, our next. So we are moving on to our next question, which states that in the figure 2 given below, AD is perpendicular to BC. AD, this line is perpendicular to BC. BD is 15 centimeter. BD is 15 centimeter. Sin B is equals to 4 divided by 5. Tan C is equals to 1. So we have to calculate the lengths of AD, AB, DC and AC. And we have to show that tan squared B minus 1 divided by cos squared B is equals to minus 1. So now first we will find the values of the sides of the triangle. Tan C is equals to 1, which means that tan C is equals to height, which is AD, and base, which is DC, is equals to 1. So if any fraction which is equals to 1, in which 2 divided by 2 is 1, 5 divided by 5 is 1, 10 divided by 10 is 1. So now we can state that every fraction in which 1 comes as the answer. So it means that the values above the denominator and numerator and denominator both are equal to each other. So we can say that AD is equals to DC. Now sin B is equals to 4 divided by 5. Sin B is equals to 4 divided by 5. So we can take this, this is sin, this is B. So this triangle is considered triangle ADB for the finding value of sin B. So we can state that this 4 is height and this 5 is hypotenuse. So we can say that we can take the ratios for x, for the values of x. So we can say that h is equals to 4x and hy is equals to, which is hypotenuse, is equals to 5x. Now this height is AD, this AD, it is the height of both the triangles, triangle ADC and triangle ADB. So height, which is 4x in this triangle, triangle ADB, and on the other side AD is equal to DC. So now we can state that DC will be equal or also equal to 4x, because DC in the other triangle is equal to AD. Now and this hypotenuse, which is this, is equals to 5x. Now by this we can say that the triangle, which is this triangle, is both the values are equal to each other, in which AD is equals to DC because of the tan C value, and sin B, which is 4 divided by 5, is equals to height divided by hypotenuse. So now by Pythagoras theorem we will find the values. Hypotenuse is 5x, which will be whole squared, is equals to height is 4x, which will be whole squared, and base is 15, which will be whole squared. So now 5 is 25x square is equals to 4 16x square plus 225. So now this 16 will be sent here. 25x square minus 16x square is equals to 225. Now it will become 9x square is equals to 225, and now this x square is equals to 225 divided by 9. So x square will be equal to 25. Now both the values will be rooted. Now the value of x will become 5. So as we have founded the value of x, which is equal to 5, we can say that in previous we have written that hypotenuse height is equals to 4x and hypotenuse is equals to 5x. So we will substitute the value of x, which is 5 here. So height will be 4 into 5, which is 20 centimeter, and hypotenuse will be 5 into 5, which will be 25 centimeter. So we can write there 25, and this x will be cancelled, and this will become 20. Now as we have founded the value, this DC will also become 20 after the multiplication of 4 into 5. So as we have found the value of AD and DC, we will find the value of AC by Pythagoras theorem. So by PGT, Pythagoras theorem, AC square is equals to AD square plus DC square. So AC square is equals to AD, which is 20 whole square, 20 square, plus DC, which is also 20 square. So now AC square will become 20 square is 400 plus this 20 square is 400. So AC square will become 800. So now we have to root this 800 by finding the value of 800. So we can take the single number common from it, 5, 2, 2 and 5. So this will become, after rooting, AC will be equal to 20 root 2. As root 2 is remaining here, it is not becoming in pair, and these pair, one number is taken out from the pair and it is multiplied and it is written out of the root. So we can say that the value of AC is 20 root 2. So now we will find our we have calculated all the lengths. Now we will show that tan squared b minus 1 divided by cos squared b is equals to minus 1. So in order to find this, first we have to find tan b and cos b. So tan b is equals to, this triangle will be considered as b is there and b is here, acute angle. Now tan has the value of height divided by base, so height is 80 and base is 15, which is 20 divided by 15. It will cancel and it will become, tan b will become 4 divided by 3. Now cos b is equal to height divided by base divided by hypotenuse. So as there is b written, this triangle will be considered triangle ADB. So base is BD, which is 15 centimeter, and hypotenuse is 25, AB, which is 25 centimeter. So now it will be cancelled. Now tan squared b, which is 4 divided by 3 whole square. This is tan b's value and it will be whole squared as it is given in the question. Minus 1 divided by cos squared b. So cos b is 3 divided by 5. It will be whole squared is equals to minus 1. So we will find this value. Four square is 16 divided by 3 square is 9 minus 1 divided by 3 square is 9 and 5 square is 25 is equals to minus 1. So 16 and 9 will remain at their places, but this fraction will be reciprocated because it is in double fraction. So it will become 25 divided by 9 is equals to minus 1. So 16 minus 25 will be equal to minus 9 divided by 9 will be equal to minus 1. So minus 1 is equals to minus 1, which we have shown. So now we are moving to our next question. So we are moving to the last question of our video, which is, if sine theta is equal to 3 divided by 5 and theta is acute, find cos theta and tan theta. So it is given in the question, which is sine theta is equals to 3 divided by 5. So we can write that sine theta is equals to height divided by hypotenuse. So hypotenuse is 3x. We will consider it 3x, and hypotenuse is 5, which will also be considered as x. So we will make a triangle here, ABC, and we will make it theta, as theta is acute angle. Now height of our triangle is 3x and hypotenuse is 5x. So we will find this side BC by Pythagoras theorem. AB square is equals to BC square plus AC square. So now AB is 5x, which will be whole square, is equals to BC will remain same because we have to find its value, and 3x will be whole square. Now 5x square is equals to 5x whole square is 25x square is equals to BC square plus 3x whole square is 9x square. So now this 9 will be sent to the other side for further calculation. Now BC square is equals to 25x square minus 9x square. So it will become 16x square is equals to BC square. Both the values will get rooted and we will get our value of BC as 4x. So as we have found the value of BC as 4x, we will find first the value of cos theta, which is base divided by hypotenuse. So base is BC and hypotenuse is AB. Base, which is BC, is 4x. Hypotenuse is 5x. So we have found the value of cos theta, which is 4 divided by 5. And now we will find the value of tan theta, which is height divided by base. Height is AC, which is 3x, and base is BC, which is 4x. So we have also found the value of tan theta, which is 3 divided by 5. So it was the last question in our video. Those students who are weaker, please like and subscribe to our channel for getting more exciting videos. And we will serve all the topics of the mathematical book of icse, which is Understanding Mathematics. And this is our trigonometrical ratios chapter. We have done 4 chapters from this book, which is trigonometrical ratios, which we are doing now, and trigonometrical ratios of standard angles. It is another chapter. Simultaneous linear equations and triangles. So go check it out. These are also very interesting topics.